have it here. So, part 2. So in just to refresh, in part 1 we went through the basics of Rust crate management and the Iron web application framework basics and serving a page. So we found out that that's not really good enough to have a working full cycle web application. So now we're going to build it out so that it can actually be that. So let's have a look. So anyway, so what we do is we go to the page definition, and we had a very simple page, so it was just defining one form. And what I've done is now I've added 2 buttons. So there's going to be one button to add and one button to subtract, in addition to the 4 numeric input fields. And when you click on the button, then it's going to call a JavaScript routine called submit form with the appropriate URL that we want it to call. And then I've added this JavaScript to handle the call. And then we get the form, and we get the form data, and then we re-encode the form data into an URL encoded format, and then we go ahead and post it, and we then get the response back. And then the response from the server is pure an HTML page, and then we just assign it to the inner HTML of the document element. So nothing that magical. Now, of course, if you're making a real web application, more high level, then you would both submit and receive JSON, and then you'd have even more JavaScript code to handle that logic. In this case, I wanted to keep it very simple, just to mainly demonstrate the Iron capabilities in Rust on a basic level. So, and then there's some error capturing logic to so that it won't fail if there's an error. And to be able to handle the page from the Rust side of things, then I've added using the router capability, which is the external crate router, and then to be able to actually handle the URL encoded data, then we have this URL encoded object. And now we actually have the more capabilities, so that when the browser requests the root, then it will send it the data generated from the get form subroutine. And then also it handles other calls or other URL requests. So here it has this when the browser asks. This is a kind of a standard feature of all browsers, that it will ask for the favorite icon. So I just made a small subroutine to handle this so that it won't crash or otherwise disturb. So it will eat up the request. And then we have the request to add, and then we have the request to subtract. And the way you get all that routing to work is that then you actually assign the, as you see here, you assign the get functions to the router, and then you actually put the router here in replacing the actual, because here we had originally, we just had this one like jump to the main page generation by default. But in this case, the router eats the request and then finds out, okay, where does it need to go now? And I just made this favorite icon. It just throws back the basic HTML header. And this, of course, you can modify to send back an icon in different icon graphics types if you want to. And then that was the get form already looked at, and then we'll just have a look at the add function, because the subtract works the same way. And I actually added a bit of debug prints here, so when the routine gets entered, then it prints out on the console, so you can see that it's actually being used, and when it exits, then it prints out also. So this creates a vector to hold the numbers, and then it calls a subroutine called extract numbers. That down here. So this takes builds a response object, and then it uses this Rust match functionality. So match something that has a value, or return a value to error. Returns result wrapped in an error. OK returns result wrapped in OK. None, no values. Some values, or a specific value. So here I tried to format the code so that when you see it, so it gets the URL encoded, form data, and then it uses the match feature to either execute the error part or the OK part. And if it's OK, then you get a map. And then here it gets the unparsed numbers. And it's the same thing, that you use match combined with OK. It didn't get anything, and that's a definite error. Or you get something, and then it'll return the numbers. And then here its last is that it will try and convert the numbers that it received into actual values and put them in the... and here it's also doing the same thing. It's using the from str and then matching against it. Did it actually fail, or was it okay with the number value? And then it exits here. So then we get all the parsed. And then we go back to let's see, add, and then it gets the numbers, and then it actually adds them together, and then it displays the result in the HTML format. So let's have a look and see how this simple application works. So I use the run command to start the server, and then we can access it through this localhost 3000. So here's the very simple web page, and then we can put in some numbers, and then we can say, okay, we add subtract numbers, and then we can also make a mistake and try and add some numbers, and then it will that was fun. That was funny. Ah, yes, because it iterates, and then if it finds one number that is not valid, then it doesn't process anymore. So if you're going to enter an invalid number, then you need to put it in the first field. Forgot that. So I've introduced an error in the JavaScript. I'm not telling you what the error is. And then you see the page loads as it should, but it's not doing anything when you try and commit the actions. So this isn't going to be a full JavaScript debugging session, but I just like to show a real basic case. To make a complete video about JavaScript debugging using the tools available would be hours of video. But anyway, let's see the real basics. So one thing you can use that is very useful is that you can actually use the if you right click, then you get into a menu. You can take a menu option, view page source, and then it actually gives you the content of what it has received from this page. So looking through this, you might actually be able to already spot what has gone wrong. But let's say that you can't figure it out. It's still not like working. So then you can go to the main menu and more tools and developer tools, and then you get this JavaScript development environment. And here we can look at source, and then we can already see that, oh, there's something strange here. Unquote reference form data is not defined. Aha, somebody sabotaged my page and put an underscore in there. Well, we need to fix directly. So this is like a really, okay, very simplistic example, but I mean, let's say you're writing some JavaScript and you write the, because there's no checking in when you're writing JavaScript in the Rust code base, then if you write a JavaScript command wrong or something, you can actually, this will do syntax checking and command checking and stuff right here in the browser. Well, then you can very easily see where the error is. So anyway, I went and corrected and recompiled them and reloaded the page, and now you see the error is gone. And then another very useful feature is that you can actually put breakpoints in here. So then we can sort of say, okay, number 1, number 2, and then you can say add. And then you can come in here and you can actually look at the data that's being, like the URL encoder, did it encode the data correctly? And you can continue. And then the other very useful thing is in the network page, you can actually see all the backwards and forwards communication. So here you can see, for example, for this add, you can transaction. Like you see, here's the local host, so it requests the first page, and then it's also requesting the icon, and then there's the add. And then you can actually look at the payload and see, oh, look, it was actually form data, and was it correctly formatted, like the URL encoded data. Or in the case of JSON, then you can actually see the JSON encoded. So I think just as a hint that when you're debugging JavaScript, I wouldn't ignore the built-in developer tools in different web browsers. I mean, pretty much any web browser, Chrome, Firefox, Internet, or all versions of Internet Explorer and stuff. They have their own. They're relatively similar. Some have more features, some have less. Some have like features like that you can set what level of developer you are. Yeah. But I say that I've actually debugged like when I've sometimes encountered even commercial services that have had JavaScript errors. I've actually been using developer tools to look at what mistake have they done, and there was actually one instance where it was very clearly a mistake, and then a couple of hours later the page started working, and I looked at the same source, and they'd actually gone in and corrected. Anyway, I hope that was useful. So now you've created your first really basic web page using the absolute baseline low-level text. So just remember, this is an internet safe, so not internet safe code. So of course, if you're going to make an internet exposed application, I suggest to invest a little bit more time in cybersecurity protecting. But it does give you a basic starting point. And The other issue is that this code, because it's built in Rust and because of the Rust design philosophy, this is automatically multi-thread safe. So if you have 1,000 users hitting this service, it's automatically thread safe and protected. So you don't have to. So this, of course, is one of the, I think, one of the huge benefits of Rust, that it will force you to write or help you write code that is concurrency and thread safe, and you don't even realize you're actually doing it, as long as you're well, actually, the truth is you don't need to like follow the rules, because you can't compile it if it's not thread safe and concurrency safe. Anyway, I'll package this up, upload this to GitHub, this example, and I'll put the link in the description. And hope you found this useful, at least as a basic input for starting your web development efforts. And see you in the next one.